half an hour ago from me, informing you that today we can finally fill the questionnaire to get your opinion on the course. And I said finally because I couldn't open it before, otherwise I would have sent an email yesterday, but unfortunately I succeeded in getting the survey opened only today, and that's fine. So the survey is already open and it will remain open until tomorrow night. So please make an effort to fill it. Maybe just wait a second that I give you some information if you still didn't fill it. Please make an effort to fill it, first because it's important information for me and the university, and second because it speeds up the registration of the transcript of your records, because of course it's anonymous, but the list of the students who compiled it is available to the system, and it's the same system transcripting your records. So in order to avoid any identification problem, please try to fill it. And as I said, the deadline is tomorrow night. Second information that I want to give to you before I give the information on the survey, some of you reported back to me that there were problems in subscribing to the exams early this morning. The problem has been solved as far as I know. So you now should be allowed to register for the exam. And if you still experience any problem, let me know, but I really hope that the problem is solved. So about the survey, as you know, because I think you already compiled other surveys during your career at the University of Bologna, is composed by two parts. The first part is a quantitative assessment. You have some questions with the closed answer, which means that you give a score to any specific question. And there are questions related to the teacher, questions related to the content of the course, the tutorials, the lecture notes, and questions related to the rules and the organization of the study plan in general. So you see that some of the questions only refer directly to the teacher, but still it's very important that you give your opinion on everything you are informed of. Of course, if you didn't attend the lectures and so you cannot say anything on the rules, that's fine. You can just leave the question and unanswered. It's not a problem. But even if you didn't attend any of the lectures, you can of course give your assessment on the tutorials, on the supporting material, etc., and also to the general content of the course. So this is the first part, quantitative assessment. Then there is a second part, which is a qualitative assessment in the form of text boxes where you're allowed to put your comments. This second part is the most important to me, and I explain you why. First, the university only considers the first part, usually, or let's say, the university considers the first part, the quantitative assessment, automatically. So that's it. The second part is not considered by the university unless there is some specific remarks that are pointed out to the attention of somebody. But on the other hand, the second part, your comments in forms of text, is the part that is more interesting to me. Now, I explain to you what is the use that is made by the university and the teacher, and in particular me, of your responses to the two parts. So the university, basing on the automatic assessment of the first part, quantitative evaluation, decides in order to allocate resources to the departments who are responsible for the organization of the teaching, and may also decide to intervene with the teacher if there is a particularly negative assessment. Usually the university doesn't intervene to give prices. It was a tradition some years ago, but now it's after the pandemics, there is no I mean, there is no consideration of on the positive side of the quantitative assessment by the university. But of course, if the assessment is particularly negative, there might be some interventions by the universities in order to mitigate the problem. Clearly, it is unlikely, in any case, that there is a direct intervention of the university on the teacher. Very unlikely. Why? It is current procedure to decide the allocation of resources based on your assessment. So if it looks like students are not interested because there are some specific questions, are you interested in this topic? Or because the students don't fill the survey, the university, of course, concludes that the topic is not relevant, it's not interesting to the students, and then may decide to allocate less resources in the future, which, of course, it's a pity if you instead think that the topic is relevant, if you think that education should be more supported on climate change, adaptation, mitigation, science of climate change in general. If you are convinced that the public deserves to be more catalyzed on the issue of climate change, of course, you should fill the survey and say that you think it is important. In this way, the university gives resources for the education on climate change. Of course, you may also say, I think in the text boxes, I think the topic is very much relevant, but the teacher is not good. This is fine. But if you want, once again, to give your support on this topic, the right way is to use the quantitative assessment. Okay, so, I mean, really your opinion matters, and try to claim your role, try to take action in any topic, not only climate change. So the survey is indeed an effective way to make your opinion matter, okay? Okay, what about the text boxes? As I said, they are used mainly by me. I am much interested in your opinion. So even if you attended only a few lectures or no lectures, I am also talking to those that are not attending today. I am much interested in your opinion, no matter if it is negative or positive. I'm interested in the opinion because no opinion, so no text in the text boxes, means to me that you have nothing to say. It's not very useful. Instead, if you liked a lot the teaching, the organization of the course, etc., please write even one sentence only. This is just fine. Fine. It means that you are appreciating it. And more important, if you have any critical suggestion, I can tell you, I really take into account your opinion. I modify the content of the teaching year after year, basing on the responses that I got. Because, of course, it's my main motivation to try to engage with the students and motivate the students to get the proper information on this topic in the best way I can. So, moral of the story, take your time also to write something in the text boxes, unless you really don't care about the topic, you don't care about improving it. Okay, so now you need, in order to complete your survey, and please note, I am required to give you this information that I'm delivering to you, and required, and also I'm really motivated to. And I am required to allow you 10 minutes during the lecture to fill it, okay? Just in order to prove to you what is the importance of the survey and to make sure that, especially those that are in the room, fill it. So you have to visit this website, val.urimbo.it, and you need a code. And the code I sent you today by email. Let me show you it on the screen. One second. Because I don't remember it, I need to, no, this is not what I wanted to get. So 1 second, please. Okay. I also make sure that the screen is shared, but I will make sure as soon as I open the message. So this is the email that I sent to you, and the code is this one. I enlarge it on the screen. Okay, 1 second. Now I'm sure it is shared, and it is this one, 565595. Okay, if you don't have any question, I leave to you 10 minutes to fill it. Okay. Are you ready? Does somebody need extra time? No. Okay, good. So, some few words before I start teaching on our plan for the future. As you may know, today is the last lecture. So our interaction in terms of lectures today is we get to a conclusion, and we have the exam that is scheduled in the dates that you see on the screen. Just 1 second that I share the screen, which I am showing now. Okay, so these are the dates for the exam. As I said, subscription is open. You're allowed to. There is the possibility, and that you see that the window is large. There is the possibility that we have more than one turn. The window is large, the time window is large. You see from 2 p.m. to 6 p.m. It's large to allow us to have more than one round of examination if the number of the student turns out to be particularly high. Of course, we will not know the true number of students who subscribe until the closure of the subscriptions, which is, I think, 4 days before each exam date. Please check when is the closure of the subscriptions, because I have the opportunity of including late students, but it is a bit laborious. And if I get many requests, I cannot guarantee that I can really include additional names. But as I said, it is quite close to each date. So you don't run the risk of losing the deadline soon, okay? And so only 4 days earlier, we will know how many students subscribed, which means that I'll be able to give you the full logistic only about 3 days, 2-3 days before the exam. I mean, the main logistic is already defined. It's in laboratory lab 2 here in this building. It's at the ground floor. I think there is a map linked on my website, but in any case, ask the reception if you have any doubt. Lab 2, okay, for the 3 dates. I will also schedule an additional date in September, and you will see it on Al-Maizani. And I need some more time because I'm not allowed now to book the room, the lab for the exam. So I need some more time. Maybe in June for sure I'll be able to. So just check on Al-Maizani for the 4th exam. And please be reminded that you will have 2 more opportunities to take the exam in January. Maybe late December, it depends on how the calendar of my teaching evolves. So late December, beginning of January, 1 more opportunity, and 1 more again in February 2025. Okay. My advice for you is to try to take the exam soon, because it's much better for you to get rid of it just after the closure of the lectures, etc. How it works, it's written here in this page. It's a quiz that will last 30 minutes. So the whole duration is take into account that we meet at 2 p.m. for the first 2 dates and 9 a.m. in the 3rd date. So after the time of the meeting, please come on time sharp, because once I close the door and once I started the quiz, it is a problem to include additional students. The only thing that I can do is to postpone you to the next round, if there is a next round, because it may be that there is only 1 round. Okay, because if the lab has a capacity of, I don't remember, I think 60 students. So my prediction is that the first call probably we will have 2 rounds, no more than 2. Even if potentially the number of students is 200, my experience is that at the first call usually I get some 70, 80. So we will have 2 rounds. The second call, usually I can resolve it with 1 round. So late students may need to go to the next date. Is it clear for everybody? Okay, good. So try to be sharp on time, please. The first half an hour is dedicated to explaining how the quiz works. It's very technical details, nothing difficult, but that I want to be very clear. I will give you all the instructions, and also I will suggest you a strategy in order to be very efficient. So let's say that the quiz starts after 30 minutes from each date. So for the first 2 dates, we start at 2:30. The quiz ends at 3. Okay, this is for the first round, of course. And then I take 10 minutes to analyze the results. So 3:15, we start with the communication of the results. If the communication is quick, meaning that I can read the list of your marks and I ask you whether you decline the mark and come the next time, or if you accept it. If you allow me to read the list to everybody, then it is very quick. In about 15 minutes more, we close the first round, which means 3:30, and then we can start with the second round, and that's it. So a round takes about 1 hour and a half. Okay. And of course, the second round may start later if there are students that want to discuss the mark individually. So for this reason, I need to speak one by one. Okay. Usually it doesn't happen, but please feel free if you have any privacy reason to ask. But I will tell you the same day. I will tell you, I will ask your authorization, your approval for reading the marks publicly, or expressing your preference for a private communication. So this is how it works. And just a few things more. Keep in mind that the quiz usually is related, not usually, it's strictly related to what you can find on the web pages without following any link. So the quiz, I repeat, the questions refer only to what you can find on the web pages. There is one lecture without web pages, but PowerPoint slides, same thing. What can be found on the PowerPoint slides may be asked at the exam, otherwise, no way. And I would also say that on the web pages there is more, and there are some very technical specifications that I'm not asking at the exam. And in particular, you can use this judgment, this criteria to assess what can be asked. Everything that needs to be learned by strict memory, meaning in terms of mathematical relationship, I am meaning, it's not to be remembered. What can be derived through a mathematical proof, only a few things only, then this may be asked, okay? Usually the questions ask the concepts, and of course some of the concepts need to be learned by memory. During my lecture, I emphasized the most important concepts. And for instance, if you see that on the website there is something that I didn't discuss during the lecture, this is very unlikely that I will ask it, because the important concepts are discussed by me, okay? If you are in doubt when you study, there is nothing wrong on your part to send an email to me and ask me whether or not the particular matter will be potentially asked at the exam. There is nothing wrong. So if you are in doubt, if you say something that is particularly tough for you, and you wonder whether it's something that may be asked, just write an email. It's not a problem. The only problem is that you may wait a couple of days before getting a reply, but I reply to everybody. So if you don't get a reply after a couple of days, please send again the email. And one more thing, of course, between today and the date of the exam, I am available for clarifications, and I prefer virtually because I see that it works really well, but also in physical presence if you prefer. It may be good if you have an opportunity to organize a discussion session with the students. It's much more productive to give clarification to a group of students rather than only one person. Because if you consult with your colleagues, of course, your colleagues may have different questions which you didn't think of, but may be relevant to you. So my suggestion, not to for saving my time, to me, it doesn't matter. I mean, I have no problem whatsoever. I am flexible. But my suggestion for you is, if you have an opportunity to organize with some colleagues a session rather than individual session of clarification, it's much better for you. If I get many individual requests for clarification, I may suggest, this never happened, I may suggest myself a session, like, okay, let's have a collective Teams call. This never happened because, you know, these requests for clarification come at different times, and usually I try to satisfy them as soon as possible. So this is why it's important that you organize yourself with your colleagues, again, if you have an opportunity. I don't think I have much more to say now, and I just want to give you some suggestions when you study. Try to make an effort. So please don't assume that the exam is by definition easy. The exam, in my opinion, is easy, but it requires some study. And I'm saying this because there is a reduced percentage of rejection in this exam. And a reduced percentage of rejection means like no more than 10%, which is quite low. But on the other hand, I think that all of these rejections are caused by zero preparation or almost zero preparation. So my suggestion, when you decide to take an exam, try to get prepared, because it's not efficient just trying, because you may think something like, okay, I just try, and then if the mark is not, I'm not happy with the mark, I decline it. But I say this for you, it's not productive. It's not productive because at the end of the story, you lose more time. Preparing poorly 3 times, it's better you spend more time than preparing well 1 time. This is, I'm quite sure of this. And the second thing, the exam is diversified, so I am a fan of diversity, so you don't get the same questions even the same day. Any student gets different questions, and also some questions look quite similar when in reality they are different. So try to rely on yourself, and on yourself meaning on your preparation, because even this is another useful information for you. At the exam, you are allowed to consult notes. You are allowed to navigate on the web and look at my web pages, and if you are in doubt with an answer. But there is a but. My experience with this exam, and you lose much more time, of course, if you look at the web pages during the 30 minutes of the exam. 30 minutes are plenty of time if you are prepared. But if for any question you need to navigate, 30 minutes are absolutely insufficient. And I say this again, if you are prepared, in 10, 15 minutes at most, you conclude everything. But if you need to look at the web for 30 times, you complete half of the quiz in 30 minutes, because, only opening the page, waiting for the connection, it takes a lot. Final thing that I forgot to say, the exam is in physical presence. I have no way of allowing students to take the exam online unless there are some motivated with documentation situations like serious illness or other, let's say, more positive commitments, like the student is preparing the thesis abroad, so I have a document from the advisor of the thesis saying, look, this student, I agreed to the movement, to the move of the student, and therefore, please, there is no problem in allowing the exam to be taken online. But I need approved demonstration, otherwise I can't register the exam. Okay, any question? Good. So let's move forward with just a brief closure to the topic of climate and energy. And climate and energy has been the subject of the past lecture and half of the previous one. There is one thing that I wanted to remark before we close this topic, and it is the concept of the water energy food nexus, which is tightly related to climate change. So there is a strong connection, of course, because I would say that this is a trivial statement, a strong connection between water cycle, food means food production, agriculture, irrigation. So this is the connection. Remember that 70% of the fresh water consumption globally is for irrigation, and energy, because we have seen the importance of hydropower for energy production and in particular electricity production. Remember, hydropower is about 2–3% of energy production globally, and about 17% of electricity production. By the way, you may find a question in the quiz like, how much of the total energy is produced through hydropower? And you may get 3 possible answers: between 1% and 5%, between 50 and 70%, between 90 and 100%. So you understand that it's quite easy to identify the correct answer. It's not necessary that you remember that the total is 2–3%. It is just enough that you remember the order of magnitude. Okay, so this is to give you an example of something that it is not necessary that you learn the number, but it is just enough if you learn the concept. Okay, close the parentheses. So there is this very tight connection between water, food, and energy. And when we talk about water, food, and energy, we are talking about climate change, because you understand that climate change is strictly related to water resources, as we learned. Climate change is tightly related to energy, because we know that 73% of the CO2 emissions by humans are related to energy production. And climate change is much related to food, because we know that agriculture is another significant contribuent to CO2 emissions by humans. Therefore, if we want to be effective against climate change, and in particular in both the possible actions, mitigation and adaptation, we need to intervene on the water, food, energy nexus. This is the context where our actions are articulated. But these 3 elements are tightly interconnected. We can't think of, for instance, working on energy and forgetting the food chapter. Because if we decide that at a certain point to use all the water that is contained into dams to produce electricity, this means that part of it cannot be used for irrigation anymore. And therefore, if at a certain point we decided I want to take the max from hydropower, the max electricity from hydropower, it means that I am impacting negatively food production. And the opposite is also true. If I decided to say, look, the dams are to be used for food production, the water is to be used for food production, this means that you limit the potential of producing hydroelectricity. So this means that we need a full comprehension of these feedbacks, links and feedbacks. Because then, of course, climate change has an effect on water, water has an effect on climate change, and the climate change has an effect on food production, not only through water, but also through the increase of temperature. And so you understand that we have to quantify, to assess several links. And for this reason, this concept of water, food, energy nexus, which may look trivial, was introduced. It was introduced to raise the attention of people and the scientific community on the interpretation of these links and feedbacks. And there is a strong research activity, an intensive research activity that is ongoing precisely on these topics. Once again, you will think that this is trivial, like it is, of course, obvious. And you may also think that everything is fully understood, because this is not true. When we talk about water cycle and connection between climate and water resources, unfortunately, there is a lot that we don't know. And when we talk about connection between water and food, there is a lot that we don't know. For instance, would it be possible to change irrigation technologies? And what is the saving that innovative technologies for irrigation may allow us to reach? Same for energy production. There are still open questions. So we have to decide whether to allocate our resources. We have important decisions to be taken quickly because, of course, climate change needs an immediate action. On the other hand, there is a lot that we don't know, and the fact that we don't know, lack of knowledge, means uncertainty. So you understand what is the importance of decision-making under uncertainty. So if we want to be effective on climate change, it's not only a matter of raising public awareness. This is for sure important. The awareness of politicians, of the public, it's for sure important. But we also need to gain the capability to decide in the presence of uncertainty, which is very boring. It is very boring topic. Decision-making is boring and uncertainty is more boring than decision-making. But on the other hand, this is the central node of the science. It's the central open mark of the science. Okay, uncertainty assessment and decision-making under uncertainty. And of course, another central open question is the way the public goods are administrated. And I try to better explain. Of course, the political will is important. This is for sure important. I think it is believed to be more important than what actually is. But of course, it is important. And here, I think that it's not just the matter of convincing politicians. We have to take into account how the system works, especially under a democratic administration. And as a consequence, we have to behave in a proper way within the context of a democratic administration. Keep into account that democracy means that elected people administer the public goods and the public safety and our health, wealth, and future. And of course, the term is quite short. It's not like a dictator that stays forever. So a dictator, in a way, may also think of, okay, I take unpopular decisions for 10 years because after 10 years, people will see that these are the right decisions and will recognize that I did it for the best, for the public best. A politician very often is not allowed to make some reasoning. The politician has to show results within a more limited time frame than the lifetime, but even more limited than 10 years. So what does this mean? It means that the vote that we cast when we attend elections is what matters in a democratic system. And unfortunately today, there is a very reduced participation of people to elections. And therefore, if a reduced number of people participate to election, of course, it becomes, the democracy becomes much weaker. And the result is that we don't succeed in getting to target. And in our case, the target is to give the consensus to the ideas, and I'm not talking about parties, ideas that are in favor of ensuring the best for the environment, for climate change. Of course, it's not the only criteria. When we cast a vote, there is not only climate change, environmental protection, there is also international relationship and economic politics in general, and many things. But the moral of the story is that if we want to be effective, in this case on climate change mitigation adaptation, we have to attend elections and cast our vote accordingly. So it's, I mean, protesting is fine. And I was too young in 1968, but in a way I lived that season, and I was a fan of protesting. But on the other hand, we need more than that. It's not just enough to protest and to make our opinion known if we want to convince politicians and then the public to act. It is participation to the social life that matters, and the elections is just one component, and the other components are participating to public debates, to candidate for elections, to stand for elections, etc. So this is a kind of concluding sentence, one of the concluding sentence of this course, because I give for granted that every one of us is interested in getting to target. But we all know that this is an open question, how to get to target with climate change. Several conferences, several calls, several actions from the media. But so far, should I say, if I am happy or not with what we achieved so far, I would say no, I'm not happy. I don't think we achieved a lot. Okay, there is some reduction of CO2 emissions, but I mean, all the plans that we are making, carbon neutrality by 2050, keep in mind that it was by 2030 until few years ago. At the time of the pandemics, we said carbon neutrality by 2030. Now we are saying carbon neutrality by 2050. In 5 years from now, we will say by 2080, because it's clear that the pace is this one. So after highlighting the importance of decision-making under uncertainty, and after having said that it's boring, I am going to close my cycles of lectures with a lecture on decision-making, and not technical. I tell you, not technical, or let's say I give some technical details for the most interesting and exciting parts of it. So I can close this lecture and go to the next one. Do you have any question on what I said? Even the students attending online, if you have any question, you are, of course, allowed to step in. Okay, so the last lecture, let me open the PowerPoint, is titled Design of Climate Change Adaptation Actions. Design, of course, is something that is in the realm of engineering. I am an engineer, as you know, so I couldn't do any other closure than closing on design. On the other hand, design means decision-making. So you can understand my introduction. Because, you know, there are some challenges in design. And the first challenge, of course, is the identification of the alternative solutions, and which is not easy. And in itself, another relevant challenge, I would say that it's the main one, is how to take into account the climate change in technical terms. And I tell you, you may not believe to that, but it's an open question. So as an engineer, I have suggested some methods for design, for sizing my interventions, for defining my strategies. So if I have to size a dam, I am given methods for that. And in some of the cases, these methods are also prescribed by the law in force or guidelines, which is more or less the same, because remember that an engineer is responsible for the design. Responsibility means that, of course, you have to adhere to the law in force, but not only on that. if an engineer makes a mistake and it is then verified that the mistake was done because the engineer went against common practice or guidelines, the engineer is responsible in the same way. And we are talking about a legal responsibility. So the engineer is required to follow the law enforcement and the guidelines. Okay, that's fine, perfect. But there is no guideline, no law enforcement, of course, on how to take into account climate change. So how can I design a dam under climate change? This is an open question. An open question means that anytime we need to devise something, so to try to quantitatively assess the impact of climate change into the future, we need any time to devise something. And this is something that is often forgotten. So to give you another example of something that is not really defined, when we talk about human CO2 emissions, and then we decide, okay, let's stop with fossil fuels, we are still uncertain on the amount of human emission that is related to burning fossil fuels. So these are open questions, and I go back to the technical design part of it. It is still an open question. Okay, so let's try to learn some more this, how we can solve the problem, how we can solve these problems. Remember that our actions can refer to climate change mitigation or climate change adaptation. And we already discussed what's the difference in scale, difference in spatial scale, difference in temporal scale. And we said that the climate change mitigation is to be orchestrated at the global level, while, and therefore it's a responsibility of international bodies. So this is why it's the United Nations usually that is taking care of it. We also said that climate change adaptation is in general, not always, but most of the times, it's a responsibility of the local administrations. Therefore, it means that while decision-making in climate change mitigation involves international politics, when we turn to decision-making in climate change adaptation, this becomes a more local issue. And it means interaction with the stakeholders at the local level, with farmers, with citizens, rather than interacting with the head of states or international consultants or international bodies like the IPCC, which we discussed. It's a different story. We will focus more on the decision-making at the local level because I think it is easier to discuss and I would say also more interesting and takes also less time. So first of all, here you see a graph which is reported in my webpage that defines resilience. Resilience is the target of climate change adaptation. So let's refer to climate change adaptation then, as I said. And the target is resilience. So the ability to prepare and prepare for climate change and plan for recovering from events that are related to climate change so that we get capability to cope with the impact of climate change. And so you see that this resilience can be obtained through hazard mitigation, and this is more related to climate change mitigation. Hazard mitigation means that I want to reduce the frequency of floods, and therefore it's more related to changing the climate and then mitigating climate change, then adapting to the change the climate, which is adaptation. So you have these two solutions, and on the right part of the graph, you see a classification of risks. So the right part of the graph is a classification of hazards, better, and it's not strictly related to the left part of the graph. In the right part, you see a classification of hazards, technological hazards, natural hazards, and adversarial hazards like terrorism. Industrial hazard and adversarial hazards is poorly related to climate change. I didn't say no relationship because there is today the feeling that climate change is also impacting a little bit adversarial hazards like terrorism through, for instance, forced migration, international tensions. And there is also the feeling that to some extent, climate change is also impacting the industrial, technological and industrial hazards because, you know, changed environmental conditions in some situation may also cause this type of hazards, or to put it simpler, a flood may cause an industrial hazard, technological hazard, and therefore you see the relationship clearly. And then you see in the bottom right part of the graph, a classification of weather-related disasters, a classification that we already know. So we already discussed what are the disasters caused by climate change in the first lecture. Here is the graph, sorry. I had a slide with a better resolution, but I think there is not much to discuss more on this. So I am skipping this slide because we already talked about the engineering part of climate change adaptation. And I like to stress in this connotation, this link between engineering and climate change, because there is some convincement, not widespread, that engineers are responsible for climate change because, you know, engineering is the science that is supporting technological development. And so far, technological development has been related to increase of CO2 emissions. I don't think that this association between this improper association of responsibility to engineering, of course, you may say that I am biased, but I don't think it's supporting the identification of a solution because objectively speaking, actually, it is true that engineering is supporting technological development, but now it's time that engineers support technological development in favor of decarbonization. And without the contribution of engineering, it's a bit of a problem to get to target. So I think that we need to solicit the cooperation between disciplines indeed. And this is why I'm stressing the role of engineering. And I'm also skipping this one because you already know about this. While I think we need to dedicate time to this slide, it is very dense, so I will take the time to discuss it. So when we talk about decision making, there are several approaches that can be taken. First of all, keep into account that decision theory is a modern discipline. It's not a very old discipline, or let's say humans always are faced and always have been faced but by the need to take decisions. So, and there are strategies to take these decisions. And these strategies are well known since the ancient times. But the science of decision theory, of decision making, intended as a rigorous codification of the strategies, of the concepts and the procedure, it's a relatively young science that dates back to 1950. Let's say, I would say probably soon after the Second World War, okay? because the Second World War indeed highlighted that emerging technologies, emerging technological development made decision-making more complicated. Okay, so you can't just decide today for complicated issue basing on your heuristic interpretation, empirical interpretation of the context of a decision. We need a rigorous theory. And we need a rigorous theory also because, you know, in the past, democracy was not diffused. Okay, there were examples in the antiquity, but democracy became widespread at the global level, and of course not completely covering the global sphere, still not completely covering the global sphere, only recent times after the Second World War, I would say. If you think that in Italy women were allowed to vote only after the Second World War, you understand that the democratic system is relatively young, at least in the form that we know it today. And under a dictatorship, in an authoritarian system, it is relatively easy to take a decision. There is a person that decides, and that's it. In a democratic system, you need a consultation with the public, with the stakeholders. We need a more complicated process, and therefore, in recent times, it became increasingly clear that we needed a science taking care of it, a rigorous codification, and a classification of methods. So the purpose of this lecture today is to provide you basic information on which methods are available, their pros and cons. And a first difference that I want to make is between the so-called top-down strategy and bottom-up strategy. And this from top to down and from bottom to up is not intended in this slide as along a hierarchy of bodies for decision. So because we tend to associate a top-down decision, a decision that is taken by only one person and affects a multitude of persons. In this case, top-down is intended along the modeling chain. We refer to climate change here. So top-down means that I start from a climate model, and then if I'm interested in electricity, I take the output from a climate model and I feed with this output another model in cascade, which is in charge of providing an estimate of electricity production. Then I can get through this model electricity availability for the future. And then I can devise a strategy and apply the strategy to the bottom layer, which is the strategy itself and the people. Okay. So I go along a cascade of models, starting from climate, and then I get to the final solution. This is the procedure that is usually followed. So we generate climate scenarios and we say, okay, in the future, we get more extreme rainfall. So we need flood protections. So I need to use a rainfall runoff model hydrological model in order to translate increased rainfall into extreme increase of floods. And then, based on an estimate of future floods, I devise like dams, levees, etc. This is the way that is usually followed. And if you look at the media, usually they say we have to expect future climate as such, and then hydrology tells us that there is more flood, and then we need dams, levees, etc., or nature-based solution, whatever. This is top-down. What is the limitation of this approach? The limitation is that if you apply a cascade of models, you get a cascade of uncertainties. So usually climate models are overly skeptical. This is fine because we want to stay on the safe side. So we don't make clear the benefits of climate change. Of course, climate change has benefits, and because if we have a warmer world, we don't need to heat it up with fossil fuels, so reduce the CO2 emissions. But we don't talk about the benefits. We talk about the negative consequences, which is fine, because we want to stay on the safe side. And then you apply the hydrological model, same thing. The hydrological model has uncertainty, and in order to stay from the safe side, we take the worst of its outcome. And therefore, at the end of the story, we get a suggested solution that is very costly. It's environmentally incompatible. People protest because usually when you say we need a dam here, people living there and also other people protest. They say we don't want it. It is the NIMBY syndrome, not in my backyard syndrome. There is a lot of literature on it. So the result is that we don't make anything, we don't act, and this is what is happening today. So, of course, we need a change of a paradigm change. And the idea of the literature has been to propose a bottom-up approach. What is the difference? The bottom-up approach is that you get a flood, we have a problem, and the problem is today. So we need a solution to this problem, no matter if it's climate change or whatever. Let's focus on the solution. And therefore, we focus on the current vulnerability. We focus on people. This is also, we start from people. So we start from the vulnerabilities. We start from the problems, the real world problems, and we identify possible solutions to the problem. And these possible solutions, of course, are sized based on the knowledge of the current problem. So basically, you may get several different solutions with the advantage that they are fit to target, and the target is the current problem. And then we have to take into account climate change, of course. Then we use climate models in order to check the effectiveness of these solutions. So we may find that a given solution is not effective against the prediction of all models. We may find that a second solution is effective against the prediction of 50% of the models. And we may say at this point, this is not bad because it solves a current problem, and with respect to the future, I get 50% of probability based on my current knowledge that is effective. So I don't get the worst climate model to estimate the future. I'm not verifying against the worst one. So I am saving some environmental resources, economic resources, and in addition, if this solution is flexible, that's perfect because I can materialize the solution. So I solve the current problem. In 30 years, if I see that climate is indeed changing for the worse, I can adapt the solution. So this is the way we should act. And this is what are called also no-regret solutions. Okay, so bottom-up is perfect and also perfect. Okay, my interpretation is biased. I'm excessively enthusiastic because I tell you what is the problem of bottom-up. And bottom-up also it's starting from the people, starting from the current problems, which is much better than starting from the science, which is very often obscure, because, okay, we get climate predictions, but people don't really understand, and they, of course, are aware of uncertainty. So they wonder, it's much better to start from the grassroots. Now, what is the problem in such a solution? The problem is that when you engage with stakeholders to identify candidate solutions, it's still problematic. So it doesn't solve the problem of coping with the opposition of people and NIMBY syndrome. It doesn't solve this problem. So, still the consultation, it's problematic. Of course, from my point of view, I would say it's better to discuss about a small dam than a huge dam. And so I still think that it's easier if we start from current problems, because keep into account one thing. Usually, governments are reluctant to work for prevention, because prevention doesn't pay off in terms of consensus. So if now you listen to somebody saying, here there is a risk of flooding, so we need to invest money, increase taxes, because I want to get prepared against it. Usually, this is problematic because it doesn't pay back in terms of consensus. But there is an exception, soon after a flood. Soon after a flood, the government gets consensus if they act. So this means that if you start from current problems and propose a solution to a problem that the people are already experiencing instead of a future problem, it's much easier. So I think this is the way it should go, but still, given that the confrontation with the grassroots, with the people, is at the beginning, we need an organized way of managing this consultation. So what is the best way to manage this consultation? So this slide describes bottom-up, okay? And it is nothing more than what I just said. And I'll have also a sketch later on of bottom-up approaches. And but before introducing this, it's here, sorry, it's here. So you see the top-down, future scenarios, design variables, and vulnerability. And with the bottom-up, but I need to give you more details in order to make you able to understand the middle column and the right column of this sketch, okay? But in the middle column and the right column, you see that the decision-making starts from the bottom. Now, what kind of decision support methodologies can we follow? Okay. First of all, let me say a little bit more about climate scenarios, which are anyway needed. So either if you use the top-down approach, you start from climate scenarios. If you use a bottom-up approach, you use climate scenarios later, but they are needed. So let me say something more about climate scenarios, because so far we talked about climate models to generate future climate. And we talked about climate models and uncertainty. Okay, and this is what this slide is saying. Okay, second bullet point, climate models. Third bullet point, uncertainty. And also we talked about tipping points. Here you see a graphical visualization of a tipping point. When you reach a critical threshold, then you may have the transition to a slow transition to a different future. And this is something that we said climate models cannot reproduce, or let's say, can reproduce only a few of the tipping points that we think could happen into the future. By the way, tipping point is really an open problem. So now I'm introducing an alternative to climate models, but it doesn't solve the problem of the tipping points. And tipping points are the subject of intensive ongoing research. And this research basically is based on the use of paleoclimatic data, and we discussed paleoclimatic data because we want to understand the climate of the past and understand if in the past, during these temperature transitions that the Earth experienced, in the past we had tipping points. For sure we had some of them, because we had periods without ice, without polar ice. And now we are in a cold period with the polar ice. So we try to understand whether the melting was sudden, if it was very slow melting, etc. And we are working with the paleo data. I got a discussion with a colleague a couple of weeks ago that reported to me some more recent contributions that pointed out that indeed the current rate of warming is not unprecedented. And he pointed this out to me and he said, yeah, we found data, evidence through ice cores that document very sudden changes of temperature that occurred in the past. So, and he said, unfortunately, our current models, they cannot reproduce these features that have been observed. So what is the conclusion? The conclusion is that climate models may be overly optimistic, but there is no solutions to this. Okay, it's related to uncertainty of climate models, and this in this case is an uncertainty that may be related to something really bad occurring, which we cannot predict. But what is tipping points? This slide, you have already seen it. What is the alternative to climate models? There is an alternative that was much used in the past. Now it's not much used, but it's now a kind of back to the scene, and it's statistical simulation. The correct term is stochastic simulation. Stochastic means you can take it as a synonym of statistical simulation. It means that you get historical data, either paleo data or observed data, and you generate future data based on the statistics of the past data. And as I said, this was a technique that was used in the past. Now it's less used. I am an advocate of going back to use it because I'm firmly convinced that for some kind of environmental risk, the prediction given by statistical approaches are much more reliable and more skeptical than the prediction of climate models. And there are some hydrological predictions that are made by climate models that are overly optimistic. So I tried with my computer and my fingers to elaborate, to analyze climate prediction and the statistical predictions. And then I proposed to water boards to use the statistical prediction because it was safer. And the uncertainty is much lower. So this is why I want to mention this opportunity, generating future climate through statistical approaches, or today there is an increasing interest in machine learning. So future climate through machine learning, which is very similar to statistics, because machine learning is trained on observed data, on historical data. Machine learning or deep learning, if there is a lot of information, like satellites can give, remotely sensed information can give a lot of information. I am an advocate of using it, but then there is a question mark open, how to take into account climate change, because if we predict the future based on the past, in the past there was no climate change. So what I am proposing, but I say I am not because I want to highlight my contribution, but because on the other end, I want to highlight the subjectivity of what I'm saying. So this is an idea that I am advocating, and it is subjective. And even if it has been presented to scientific conferences, some papers, not many, but some papers, because it's a recent idea. And the idea is that we use climate models to predict the change, not to predict the future, to predict the change. So we run a statistical model with changed statistics. And what is suggesting the change in statistics? The climate model. And I'm not the only one proposing this idea. It is an idea that is also proposed by several other researchers. It is generally not readily accepted by climate scientists, because climate scientists, if their science, they prefer to stick on physically based models, not machine learning, not statistics. On the other hand, there is to say that this is a compromise, because if you predict change by using climate models to feed statistical models, that's okay. I mean, it's a compromise. And this is the way it should follow. And I prefer to use the climate models to adjust the statistical models rather than the opposite, because there is also the opposite way possible to use the statistical models to adjust the climate models. And this is called processing, or bias correction, whatever, post-processing of climate models. So I prefer to make the post-processing of statistical models, because I tried by referring to the region of Bologna for several consultancies that I had to make for the water boards, and I found that it's much easier and much more reassuring if one has to take the responsibility of what is done. So for the engineer, I think it's much more reassuring to post-process the statistical models rather than post-processing a climate model. Okay, I think, let me see the next slide. Let me just check. Okay, I think we can stop here, because now I need to go back to the website, because there is a part, a few things that I want to discuss with you that are not included in the slides, but are only on the website. Remember, to study for the exam, your reference is the web page, is not the PowerPoint. I already told you, the PowerPoint are for teaching, not for preparing the exam. Okay, don't make this mistake. So I think we can stop 15 minutes and see you at 4:30. Any question? No. Okay, you're still in time when I come back. Discuss the solutions. And then, of course, the second step is the evaluation of the alternatives, system performances, vulnerability assessment, which means that then you take into account, for instance, climate scenarios, possible futures, and you see what are the conditions, the vulnerabilities of each possible solution. And then there is a subsequent step in which you may tune the solutions, may tune your assessment of success basing on the future climate. And finally, there is one thing that I didn't say. Finally, you try to establish the likelihood of each future scenario, each possible future climate. So in a first stage, you get all the possible future climate, and you just look at all the possible configurations. In the final step, you get instead you get an evaluation of their likelihood, if it's possible. Okay, because in some of the cases you may have for different climate models an indication of their likelihood. And when you associate the likelihood, then you obtain an estimate of the risk. Because as we will see in a few minutes, risk given by a possible future is related to its likelihood. So if the possible future is not likely, it doesn't portray a big risk. Okay, as we will see in a few minutes. So this is the step, and this is what is depicted in this. I go to the PowerPoint presentation, just 1 second, in the graph that I showed you before. This is robust decision-making, candidate strategies, evaluate strategies against scenarios, vulnerability, and then you may tune the strategies, and you can go back here. But in any case, you start from the candidate strategies, okay? Regarding my website that I was showing to you before, give me, please, I noticed an inconsistency. There is an error. I will fix it by, let's say, today, tomorrow at the latest, okay? There is an inconsistency if you compare this figure. I noticed it when I was reading, but I will make the change later. Okay, now here on the right, you see a different method which is called decision scaling. Decision scaling was introduced 10 years ago. It's very similar to robust decision making. It's still a robust method, but there is different workflow. And because the decision scaling was conceived specifically for climate change problems, while robust decision making is more general. And basically, decision scaling focuses in a different sequence. First of all, it starts from the problem. So, for instance, a flood occurs. So the problem is risk of flooding. While a robust decision making starts from candidate strategies, it's not very different. The result is more or less the same. But in the context of climate hazards, given that there is more proactivity soon after a disaster, it is the authors suggest to start from vulnerabilities, and then we evaluate climate scenarios because we want to see if in the future climate the vulnerability is exacerbated or not. And then they say that we can use further information like statistical models to refine our estimates of vulnerability, and then we elaborate strategies. We elaborate the strategies. We evaluate the effectiveness of our strategies. It's a bit different, but it is a difference that is related in the workflow, not really in the concept. It's still, the concept is still bottom up, still robust decision making. Of course, I'm not getting here into the details of the measures, how we evaluate the strategies. We are not getting into the details. I will give you an example, just to close this lecture now, of a measure that we can use to assess vulnerabilities. Okay, so now let me give this example. And the example is based on the computation of risk. Okay, so I just introduced risk, and I said that risk is different from hazard. Hazard is the likelihood that a flood may occur, a flood, an earthquake, or whatever, an heat wave. This is likelihood of a climate disaster occurring is likelihood is hazard. And risk is the damage, is a measure of the damage that we get from it. And you understand that if an event is very unlikely, the damage that we get from it, the damage that we get from this type of event is reduced, not because it is reduced the damage that we experience if the event occurs. The damage is reduced because the event doesn't occur, is unlikely. So risk is a measure of the damage taking into account the likelihood. And the likelihood is the hazard. So let's get into more details and into a clearer explanation, hopefully clearer. Okay. And in order to get it clearer, let me refer to the website because so I can magnify the equation. Let's define the risk in this way. 1 second. Okay. Let's define the risk in this way. I am selecting the relationship here. The risk can be estimated for associated to a given event. Okay, so risk of flooding, and the risk related to a flood of a given magnitude. Okay, it is can be expressed, and this is an international guidance of the literature, through a simple product of 3 factors. P is likelihood of the event, and in Italian it's called pericolosità, just to understand in Italian what is the term of reference. So you see that if probability is very low, the risk is low. E is the exposure, it's the damage that we get if the event occurs. Okay? So let's suppose that the event occurs, E is the damage. So of course, a rare event, a very infrequent event, gives a lot of exposure, a lot of damage. But the probability is low, the likelihood is low. So the risk may be, who knows, it depends on the value of E and the value of P. There remains a third factor, which is vulnerability. V. What is vulnerability? Vulnerability, let's suppose that the flood occurs, but I have a levee, and the levee is so high that the land doesn't get inundated. So I have no damage. No damage. This means that, because of course we have to take it into account, we have to find a way in the computation of risk to account for actions that we can take to mitigate the risk. And this is precisely adaptation. So if I build a dam, the probability of the flood is the same. Likelihood is the same. The damage that I get if the land gets inundated is the same, but the land doesn't get inundated because the water volume is stored into the dam. Some comments on the units and the range of variability of these 3 factors. Probability, as you may know, is cumulative probability of an event is confined in the range of 0, 1, and it's dimensionless. Vulnerability, by definition, we express it as a factor ranging in the interval, again, 0, 1, where 1 means absolute protection, 0 means no protection, and it's dimensionless. E is the exposure, and it doesn't have a predefined range. We only say that it's limited to 0 and positive values. It's limited to positive values. And there is no upper limit, because there is no upper limit to the damage you may get from an adverse event. And what is the unit? The unit depends on the criteria, on the measure that you adopt for assessing damage. So the damage may be measured through loss of lives, and then the unit is lives, the unit of exposure. Or the damage can be quantified in economic terms, and then the unit is economic terms, economic unit. This means that given that P and V are dimensionless, the unit of R, risk, is the same as the unit of E. So you may say that a flood has an exposure of 1 billion euros. The vulnerability is 0.5 and the probability is 0.5. This means that the risk is 250,000 millions euros. It's 1 billion times 0.5 times 0.5. This is very trivial, but it is also very meaningful, because it highlights what are the factors that are influent on our concern of being exposed to an adverse event. Let's suppose that you don't have anybody living there, no goods, no exposure. Even if the event is very likely, even if there is high vulnerability, you don't care. Let's suppose that you don't have any environmental impact, anything. Or let's suppose that you get fully protected. By the way, when you talk about natural hazards, usually you never reach full protection. You always have to accept a residual risk. By the way, okay? It's impossible to say I get fully protected against an earthquake. It's impossible, because it may happen something really, tremendous, okay? Something really unexpected. Okay, so it may be a nice exercise to try to make a graphical representation of, a possible progress of these three factors and their product. So this is a possibility. The graph that you see here is a possibility. So we can draw on the vertical axis exposure, vulnerability, and risk. Okay, so let's consider risk as the last one, because it's the result of the product. And on the horizontal axis, you can put the intensity of the event. The intensity of the event is associated with probability. Decreasing probability, higher intensity. And this is a classic of environmental sciences. When we talk about disasters, the most relevant the disaster, the lower the probability. Fortunately, we don't get extreme earthquakes frequently. Usually we get extreme earthquakes very rarely. So, depicting the intensity of the event on the horizontal axis means that the horizontal axis is moving forward in the direction of decreasing probabilities. So let's look, for instance, at exposure. Exposure, as the intensity of the event increases, typically remains zero up to a certain extent. So the riverbed is autonomously capable of conveying downstream a certain amount of flow. And until the flow is confined into the riverbed, you get no inundation, no exposure. For increasing exposure, you get for increasing intensity of the event, you get increasing exposure. And the pattern of this curve depends on the context. What you see here on the screen, the blue line, is just a possibility. Usually, you get a sharp increase of the exposure for increasing intensity of the event up to a certain level where, even if the event keeps increasing, you reach the max of the exposure. It may be. usually it is asymptotic, but it is quite frequent that the convergence to the asymptotic value becomes very slow when the intensity becomes very large. But in some cases, it may also happen that there are thresholds in this curve, sudden increases of exposure in certain conditions, like a tipping point. But this is a possibility, this blue line. Vulnerability is more or less the same, of course, in a different scale, because vulnerability is in a range that is different from that of exposure. And vulnerability is remains zero up to a certain extent. Think of a levee. A levee, until the flow is confined into the levees, between the levees, there is no vulnerability. So the city is protected, the land is protected, is zero. But when you reach a certain level, maybe the levee, you may have a sudden jump to 1, because the levees, when they are exceeded, they collapse. So vulnerability may go from 0 to 1 very suddenly, like in this case where you see that there is an increasing value. Now let's look at the yellow, orange line, risk. Risk is given by the product of exposure, vulnerability, and probability. Probability becomes much lower as we go right on the horizontal axis, keeps decreasing. Therefore, depending on the pattern of probability, vulnerability, and exposure, typically risk remains zero until either vulnerability or exposure are zero. And then it starts increasing. But given that probability goes down, typically we reach a max of the risk, and then the risk decreases. Because while vulnerability and exposure converge to a max, probability keeps decreasing. And therefore, typically we identify an intensity of the event that gives the max risk. And this is interesting. This is interesting. Because it involves some consequences. First, this is good from the point of view of allocation of resources. It's good because usually we get protected up to a certain intensity of the event, and therefore we avoid over-allocation of resources. So it's in favor of taking action, this result. In fact, if you look at the European Flood Directive, it gives the recommendation to size the levees for a probability of 1 over 200. It means 0.5%, a probability of 0.5%. They give this suggestion because they are aware that usually the risk of flooding has a max in correspondence with that probability. So this is good on the one hand. On the other hand, this implies that we don't care about very exceptional events. So we don't consider them, to the extent that even the exposure curve, usually, it is stopped when we reach the max of the risk. There might be like a tipping point soon after that, a sudden raise of exposure, and we ignore it. And this is why I have now a paper under review, which is called the Sword of Damocles, titled of the Impossible Flood, because we are discussing there, it's under review, we are discussing there, it is under review, but the preprint is already available on the web. I'm not sure whether or not I already suggested you to have a look at it, maybe. And we discussed there the risk associated to neglecting very unlikely events. And actually, it turns out that under climate change, what we think is very unlikely is not so unlikely. And in fact, we have had at the international level several examples of unexpected floods recently with a return period, with a probability lower than 0.5%. And to give you a few examples, the flood in Germany in 2021, the flood in Libya last year, and the flood in the Romagna region last year. These are three examples of floods that, the probability associated to them is much lower than 0.5%. And this means that actually it was a disaster. And it was really a disaster, and the community were not prepared. To give you an example, in Germany, in an hospital, they had to carry the patient downstream by hands, by arms, because the electric network failed, and also the backup plant of the hospital failed, because they got the water to a level that was unpredictable and unpredicted, and therefore they were without energy, and they had to carry the patient along the stairs by arms. So you understand, sometimes during disasters, things happen that are really unpredictable. This is an example of a measure that can be used to drive our bottom-up approaches, our robust decision-making, how we assess the efficiency of measures. This is a possibility to use risk. Okay. The lecture moves forward with a discussion of uncertainty of these estimates for vulnerability and exposure, and the effect of nature-based solution and structural intervention. We forget about this because we don't have any more time, and also what follows is really a detail. The concept is here. Okay. So actually, we still have some minutes left because I wanted to keep some minutes for maybe questions, comments that you may want to address directly. Questions also on the exam. But of course, you are not obliged to ask questions. And if you don't have any, I want to thank you. And even if I understand the reason, so I'm not really complaining or criticizing, even if your attendance was reduced in some lectures, but I understand why. And also, we are also teaching in stream because I want really to be flexible on your behalf, for your benefit. And so thank you very much, and I hope you enjoyed it. And in any case, if you have any late question later on, you receive the instructions on how to contact me. Questions? Okay, nothing. So let's stop the recording. A second. Okay, good. Thank you very much. Grazie. Let's keep in touch if you have any need. And you may receive also some emails from me. Be patient, because I also want to keep you informed about the other courses that you may attend the next year, and if you are interested, or other initiatives that cultural initiatives we are organizing for providing more information on climate change. So you will get some unsolicited emails from me, and you will be patient and bear with me. Thank you. Grazie. Grazie mille.